Hello and welcome to part 2 of properties of exponents. Last time we did this sheet of paper, did some notes on the properties of exponents. Today we're doing some practice on this video. So without further ado, here are some problems. Says simplify, your answer should contain only positive exponents, so no negative exponents. Remember that implies is that if you do have a negative exponent, like x to the negative third, then we are going to have to make that x 1 over x to the positive third. So they're going to be fractions. Or if you had something like x over y to the negative third, then we're going to have to change that as x to the y to the positive third. Because anytime something is in the bottom, it's going to go to the top. Anything it's in the top, it's going to go to the bottom. So it says to do that, do not do negative exponents. But that might not happen for all of them. So in this problem, it says 2m squared times 2m to the third. Notice that in this one, it does have regular numbers now as well. It has a 2 and a 2 plus an m. So when you do these problems, you are going to do the 2 times the 2. So 2 times 2 is 4. And we have dealt with those 2's now. When it comes to the m's, you have an m squared and another m to the third. Since they are two separate bases, m and m3, that means you can add the exponents. So 2 and 3 make 5. So the answer is 4m to the fifth. Once again, regular numbers you can multiply, and then things with exponents, you add the exponents when there's more than one. For number 2 here, notice that it also does have a regular number. It's not an exponent, it's just a regular number. Because it's there, that means our answer is going to have it as well. There's nothing in front here to actually multiply it with, so we're just going to have a 2. And then you have an m4 and an m negative 3. They are two separate things. They both have a base, so we're going to be adding the exponents. So a positive 4 and a negative 3 is just a 1. So 2m to the first. 2, or just 2m, because anything to the first power is just itself. So the answer is 2m. If you want to go ahead and pause tries 3 and 4, see if you can do those. 3 might be difficult because of the negative exponent, but 4 should turn out okay. So number 3, you have 4 times the 2 is an 8. R3 and R2. Negative 3 plus 2 is a negative 1. So you end up with r to the negative 1. Since r is to the negative first power, that is going to become the fraction part. Notice the 8 does not have a negative exponent. Because the 8 does not have a negative exponent, it gets to stay where it is, just like a regular 8. It's the r to the negative first that's going to go to the bottom. So this would be an r to the first on the bottom. And that's what you get. Number 4, you have a regular 4 and a regular 2 that multiply to 8. And then an n4 and an n negative 3. You get to add the exponents, so 4 and negative 3 makes a 1. So your answer is 8n with no exponent, because anything to the 1 power is just itself. All right, here's 2 more problems I wanted to go over. If there is no exponent, like this k has no exponent, then you need to fill in a 1. It is a k to the first. That's important when you're multiplying the k4 times the k1. Because otherwise you might accidentally say that this is just k to the fourth again. But since this is a 1, it's going to be a 4 and a 1 is 5. There's 5 k's total. There's 4 k's here and another k here. So 4k's and another k make 5k's. And then this 2 and this 4 can multiply to be 8. And then, oh boy, let's have some fun with number 6. In number 6, it looks like there is a number here in there. So we can multiply those to get 4. I have an x to the third and another x over here. So we're going to take those x's and put them together. This one's a 3, this is a -1. So we're going to add them. 3 and a -1 makes a 2. So you'll have an x squared, x2. And then lastly, we have a y3 and a y -3. So y, and then the exponent will be -3 plus 3, which is 0. But the thing is, you have y to the 0, and the other property we talked about was that anything to the 0 power is just 1, which means that's just going to go away. It's going to be completely gone. Your answer is going to be 4x squared. Nothing more, because the 0 power just cancels it out. Okay, if you want to try 7 and 8, you can. I'm going to go over it in 2 seconds. Okay, 2 times 3 is 6. These two things do not have the same base, so it's just going to be y squared x. You cannot combine them because they're not the same. If you want to write it as 6xy squared, you can as well. It does not matter. The order does not matter. Just make sure you're putting the number first. But after that, the letter order does not matter. In this one, you got a 4, a v3, and another v. So you have 3 v's and another v. That's a total of 4 v's. So v to the 4th power, because of that magical invisible one. And u doesn't have another u, so it's just going to stay the same. Next up, number 11. I'm skipping a couple of these. Anything to the 0 power is 1. Ta-da! That's it. Anything. Doesn't matter what this is. Anything to the 0 power is 1. Number 14. In this one, be careful that when you have 4a to the 3rd squared, do make sure that you have to square everything inside of here. So you do have to square the 4. 4 squared is 16. And then a to the 3rd squared, this is a single base to 2 exponents. A single base to 2 exponents, you multiply them. So this would be a to the 6th. Once again, I want to emphasize, because a lot of people mess this up, a to the 3rd squared is different than a to the 3rd a squared. You see the difference. Make sure you see and understand the difference. Double exponents versus 2 bases, but they have the same base. This one you multiply, and this one you add. Very important that you know the difference. All right, a couple more on this page I want to do, and then a couple more on a different page I want to do. Once again, if you ever have trouble understanding what I'm talking about, feel free to pause it at each step or to rewind and watch the whole problem over again. Or after I go through a problem, to pause it, rewind a little bit, and then try the problem on your own, and then unpause it to see if you get the same thing again. Here we go, number 21. Well, first of all, it's going to be a fraction. I'll get that out of the way. There's no number up top, but there is a number on bottom. That'll just stay there. Regular numbers just work as regular numbers. And then with the r's, there's 2 ways to do this. The first of all is to do what we talked about before, which is to subtract the exponents. R squared over R3, you would do 2 minus 3. And 2 minus 3 is negative 1. So you would have r to the negative first. But since you have a negative exponent, that means you're going to flip it to the bottom, right? The negative sign means it's going to flip to the bottom and be over there. And now since there's nothing up top, you just put a 1. And that is the first way you can do this. The other way you can do it starts out the same way. You end up with the 2 there. But this time, when you look at the exponents, what you can do is instead ask yourself, well, which exponent is bigger? Because whichever exponent is bigger, that's where your answer is going to end up. So like we had x squared over r to the third. I'm sorry, r squared and over r to the third. Because the 3 is bigger, your r is going to be on the bottom. And then the question is, well, what's the exponent? And then you just subtract them. It doesn't matter the order. 2 minus 3 or 3 minus 2, you get 1. The difference between 2 and 3 is 1. And that 1 will be on bottom because 3 is bigger. In which case you just get the same thing again. Same thing would work over here with number 22. You have an x to the negative 1 and x to the 4th. Because 4 is bigger than negative 1, your x is going to be on the bottom. You just don't know what the exponent is yet. But it's definitely going to be on the bottom because x4 is bigger than x negative 1. If you find the distance between negative 1 and 4, that distance is 5. 4 minus a negative 1 is 5, right? 4 minus a negative 1 is 5. So this is going to be to the 5th power. And as for the numbers, it's just a 4 on bottom, so it's going to be a 1/4 like that, or to clean it up. That's the final answer. You could, of course, say x to the negative 1. Negative 1 is going to take this and put it in bottom, so then you still end up with x5 in the bottom. And I still have a couple more problems I want to do, but once again, this has reached like over 12 minutes, so I'm going to make a third video. Woohoo! See you there.